This is 100% a continuation of yesterday.
Okay.
So yesterday, we did various ways of counting up how many possibilities things can happen. And I believe I mentioned it in class, but the reason we were doing that is to work on probabilities. Because to figure out probabilities or the chances of something happening, you need to know how many things are possible. And there definitely are some probabilities that are super easy that you're used to. Like you guys, I'm sure off the top of your head, already know flipping a coin is 1 out of 2, or 50%. Because that's probably something you've done before. Like, it's a very common way of making a decision. If two people have an argument and, they neither wants to change their mind to what they're deciding, sometimes they compromise is to just flip a coin because it's a fair way to pick that's not biased. Like, it's not going to pick one side or the other, it's just going to do it. And my guess is that's probably the second most common probability that you're used to. The most common would be weather, which is by far the most annoying. But I guarantee you've heard your parents talking about weather before. And maybe you guys watch the news as well, I don't know. The parents are very famous about talking about the weather because it takes up a big part of their day, right? They want to talk about what's the chance it's going to rain, what's the chance it's going to snow, whatever it is. Because some people don't like their day to be ruined by rain or snow. And so that's the percentage chance that the weatherman always talks about is a probability. So probability is just basically what's the chances of something happening. Like that would be a common sense term. The weird part about probabilities is there's a bunch of ways to write the answer. And that's what that little graph on the bottom is. And I can scroll up after a little bit if you want me to. See, that's why I kind of told Ava that spot doesn't work very good because it's hard to see.
Yes, like to see the board?
Yeah. Hi. Messages. It's a pass for me to get out of school. What? That is not fair. I want one, Estella. Can you have your mom or dad write me one?
Oh, yeah.
That'd be cool.
Okay.
Thanks. Does anybody want me to scroll down so they can see that chart better? I don't know. It's hard for me. I can't tell if you guys can see bottom of the board or not. It'll be worse next year. So next year when they get the new whiteboards, they're smaller. So some of the teachers I think already have them. Like I know Mr. Howard has one. It's basically just a big TV, but it's smaller. And seems weird to me that we're getting more and more people in every room, but getting smaller and smaller screens. No, it's a lot clearer for one, so it's probably. Oh, really? Good. That's good to hear. So it's easier to see than something like this. About the same. Okay. I just known his. I thought it was funny because they mounted it so low so that you can't see like the bottom third of the screen. He's got the science rooms have those big desks in the front, and they mounted his screen below the desk. Okay. If something has a 0% chance of happening, that means it cannot happen. That means it's impossible. If something has a 50% chance of happening, that means it's equally likely. That basically is saying that it could happen, it could not happen. I mean, most of you are used to a coin or taking a shot like a basket. Like if you shoot a basketball, it's either going to go in or not. That would be your two choices, equally likely. And then a 100% chance means it has to happen. Okay, so this is probability. Sometimes writing the answer as a fraction is easier. Sometimes writing it as a decimal is easier. It really doesn't matter. Do know that when we get to our test, you can write the answer however you want, and I will understand it all different ways. I believe in the answer keys, they usually don't write all three ways, they just write one way. But know that you can. Okay, there's two types of probability, and that's what we're going to cover in this section. My guess is you already understand the difference, but maybe you've never really been told the difference. So theoretical probability is what should happen. Experimental probability is what does happen. And it's second hour and I'm super tired already.
Me too.
I just hate it. Ever since I got COVID, it's like I get tired super fast.
Did you lose your taste in smell?
I did not.
That's good. Oh, that's good.
I actually wouldn't have minded it. Would have been like a natural diet. I could use that.
But when you're really craving something, then you can't taste it.
That's true. That would have killed me. Like if you really wanted like pizza or something greasy or like something sugary. Yeah, that would. My mom's been like that for a lot of years though. She lost her smell from.
I had COVID right before Thanksgiving.
Oh, that's right.
Couldn't taste or smell. It was terrible. Because I was so hungry for food.
Yeah, my mom's been that way for a lot of years now because she had a sinus infection, and then from it she could no longer smell, which means she can't taste. Okay, theoretical probability. I'll give you an example. You roll a dice. What's your chance of getting a 2? Are you guys telling me you don't do dice often? 1 in 6. I figured you'd be good at that one just because you've done it before. So it's 1 in 6 because there's 6 sides on a dice, and so you kind of know what your chances of getting that is. However, if you rolled a dice 50 times, you might find out that rolling a 2 doesn't happen 1 in 6 times. You might find out it happens, let's change it to a percentage. So 1 in 6, I think, was like 14% or something. Is it 16.67? 16.7%. You might find that you actually roll a 2 20% of the time. That would be considered experimental probability. Because if you actually do an experiment and find out how often something happens, that's experimental probability. Now that could happen because like maybe your dice isn't very even. You know, like maybe your dice got a chunk taken out of it by your dog chewing on it. That happens, it's not going to roll perfectly. They wouldn't let you use that dice in Vegas. Experimental probability, another experimental probability one for sports is actually the most common. Basketball is probably an easy one. When somebody goes to take a free throw and you're watching an NBA game, a college game, whatever, they usually put up their percentage of free throws made, correct? Like they might say this person's like an 87% free throw shooter. And that's because they have previously made 87% of their shots. The theoretical probability of making a free throw is 1 in 2. You're either going to make it or not. But the experimental probability is how often you actually do. So there's differences between the two, and I think you kind of naturally know them, but you just might not have really ever separated them before. But the whole point of probability is to predict how likely something is to happen in the future. Okay. Now, if you want a definition, probability is the number of desired outcomes divided by the number of outcomes in the sample space. That sounds way worse. Have you guys ever heard of sample space before? So didn't you guys, I'm trying to remember, didn't you guys have some probability in Algebra 1? It might have been different depending on what grade you took it and which school you took it at. Yeah, which is partially why they now included Algebra 2 to guarantee that you have it. It used to be that the probability and statistics was in Algebra 1 instead of Algebra 2. But then what we ran into was from the different junior highs and high schools and things like that, that people take it at different places, and so they end up getting a different class. Sample space is all the possible things. It's basically like every possibility. Sample space is what we were figuring out yesterday. So here's an example of probability. An album that has 5 dance songs and 7 slow ballads. Great album. What is the probability a random song chosen? Because when you put it, I was going to say put it in your CD player. God, you guys don't really even use that. When you guys hit shuffle, when you hit shuffle on your phone, it goes to a random song. And so what is the chances that next song is a dance song? Well, the desired outcomes are how many dance songs there are. Well, there's 5, okay? Sample space is how many types of songs there are altogether, which would be 12. So you have a 5 out of 12 chance that the next song is a dance song. I guess slow ballads are pretty much dance songs too, but those are like slow dances.
Can you just go up real quick so I can get them?
I certainly can. Did anybody else need that? Want that up there yet? Okay. See, you guys are denied the fun of something actual physical that you take to make it play music. Like, it's obviously nice to do it on your phone or something because you guys have, you have a lot more songs to pick from. I mean, that's an understatement. And you don't necessarily even have to buy them. You just go on Spotify. Right.
Unless you like no ads.
Yeah, well, whatever. I'm pretending that nobody downloads or, things like that either, but, before, you used to have something physical to be able to listen to it if you weren't going to listen to the radio. So it was either a record, which was a while ago. Now it's popular again. And then it was an 8-track, which is a weird tape. Then there was a tape. And then there were CDs. And now it's just all digital. And it's kind of fun to have something physical to do. Like, these are, I don't want to say these make more sense from that. Because a lot of times you used to do that with CDs. You just put it on random because you didn't want to know what song was next. I don't know. Anybody have any questions on what's up there? Okay. Dice. So here, what I have up here is a 2 dice chart. These are all the possibilities of rolling 2 dice. What is the probability that the total rolled is 10? Can you guys try to do this one on your own?
Wait, are the blue and the white different dice?
Correct. They are different colors to distinguish that they are separate. First thing you need to do is figure out how many different ways can you get a total of 10. You'll notice patterns in the chart too.
I forgot I lost.
That's why I was talking about the patterns. I'll help you guys. It probably is really hard to read from your desk now that I think about it. Okay, so what do we have? We have a 6 and a 4. Okay. Got a 5 and a 5. We've got a 6 and a 4. I should have called this a 4 and a 6, I guess.
Wait, I'm confused.
6 and 4 is different than 4 and 6.
Why are you highlighting?
These are the ways that you can get
Oh,
a total of 10.
I see.
So these would be the desired outcomes.
So would it be 3 out of 10?
No. Where'd you get 10 from?
That was like 70 dice.
There's not 70 dice. Oh my
So-
gosh.
So there'd be 3 and then over the total?
Oh, actually, there is 72 pictures up there.
Yeah,
So it'd be
so
3
they
over
counted.
72?
Okay, so the probability of rolling a 10. I'm going to write it like this. Because then when I write that, then somebody knows exactly what you're answering. Probability of rolling a 10. There are 3 ways to roll a 10. That's the desired outcomes. How many are in that sample space? Are you guys actually just sitting there counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Yep.
Oh God, don't do that.
Why not?
Because it's a chart. You 6 by 6.
Oh, I could do
Multiply.
4 6.
6 times 6.
I thought each, like, they're different dice, the white and the blue, so you count them separately, right?
We'll see how I have them highlighted, right? So I highlighted a pair at a time because you throw 2 dice.
Oh.
So there are 36 pairs up here.
Oh, see. Yeah.
Oh, I see.
So probability of rolling a 10 is 3 out of 36.
Can you write this down? Yeah.
Now you guys aren't old enough to gamble yet.
I will in 4 months.
In 4 months you can gamble. Okay, look at that. Um,
Small.
I'll pretend that you guys don't ever gamble with your friends.
I'm tired.
Oh.
Ooh, wait, how's this? Do you guys ever do the dice game at like holidays with your family, like presents and stuff?
Yeah.
So,
Yeah.
like if you got a bunch of people in your family, it's way too expensive to just give presents to everybody. So a lot of families will do the dice game, where each person brings 1 present or something like that. You know, some kind of rules, and then you pass around the dice in this little pie tin and you roll it. You get a 7, 11, or doubles, and you can pick a present. A lot of you never done that?
I do it every year.
Oh, okay. Yeah, I don't know. My family does it because we've got a lot of people. So,
It's a dice game.
and I run into that with some friends and things. Well, what's your probability of rolling a 7, 11, or doubles? Why don't you figure that one out? What's the probability of rolling a 7, 11, or doubles?
You could roll each person rolls dice, and the number you want is the number that you're putting.
Yeah.
Or like sometimes we do, like punch a piece of paper, and each person picks out the number, and whatever number you want to be last, because then you can.
Did you notice how when I highlighted the 10s, it was at an angle? It's always going to work like that, where there's going to be a pattern on that chart. So 7. $11. And then doubles is
Can you just explain that?
there's always going to be patterns when you're finding certain things on dice. I highlighted a total of 7. So like the 2 dice add up to 7. 1, 2, 3, 4, 5, 6. Okay, so I'm going to write this down. 6 sevens. There's only 2 ways to get an 11. 6 and 5 or 5 and 6. And then doubles, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Why did I put a comma?
I'm
There's 6 ways to roll a double. So if you're playing the dice game and you roll a 7, a total of 7, or you roll a total of 11, or you roll a doubles, you get to grab a prize. And so if that happens, it looks like there are 14 ways to roll a 7, 11, or doubles
36.
out of 36, which means almost half of the time you should be grabbing a prize.
well, like there's different ways to roll 3. I didn't
Yeah.
realize that.
Yep.
Is he just using this as an example?
Oh, I see.
Yeah, no, I just picked a different example.
Oh, okay.
You think so deeply into why he
So can you not like?
I don't know what you're trying to ask.
I don't know either.
I mean, when you think of it, ask it.
I will. Like, why didn't you put like when you did like the 6, like on the other side? Can you go back really quick? When you put like 6 plus 2 plus 6, why didn't you do like how many doubles are equal 3 of the dice? Like there's pairs. That
So what I wrote in the parentheses is what we were looking for specifically. A total of 7, a total of 11, or doubles.
and you just randomly picked out as an example.
Yeah, because that's what my family does for the dice game.
Oh, okay.
It was no different than me randomly picking a roll of 10. Like, just an example. It can be whatever. It's actually pretty funny at our family because my sister gets super into it. She gets really vicious. Because we have a steal round. Yeah, we do the first round where everybody picks a prize, opens it, or a couple prizes, and then everybody realizes which prizes they want, and so then we do a steal round, and my sister, she gets way into it. One year she stole it from my 5-year-old daughter.
Oh my god.
It was kind of funny, but kind of sad at the same time. Okay, now, sometimes you might be trying to find out the exact opposite of the information you have. And so we can find the answers by using complementary, complementary probabilities. Now I have a 1 there. That 1 represents 100%. So if you write 100% as a fraction, it's 1. So if we're trying to say, I put an example underneath, which probably makes more sense. If you're trying to figure out what's the probability it's not going to rain, and the weatherman told you that there's a 20% chance it's going to rain,
You would put 20 right there for him.
then you would do 100% minus the 20%. And then that means there's an 80% chance it's not going to rain. So if you're ever trying to find the exact opposite of what you're given, then you can always subtract it from 1 if it's a fraction, or 100% if it's a percentage. So like this one, Battleship. It's a pretty old game now. It's been turned into a movie, which the movie was almost nothing like the game, but that's okay. I thought the movie was awesome. I like bad movies.
You like what movie?
Bad movies.
Okay.
Like action movies?
No, like B movies.
Like what?
They call them B movies.
Like they're bad.
No, they're B as in they're like lower grade,
Like not really good movies?
yeah.
Oh, how do you like those?
Because they're kind of funny.
I was into those.
Have you guys ever played the real Battleship game?
They're too young.
Yeah.
Okay,
But
maybe you went to your grandma and grandpa's house and that was like the only game they had or something.
Indubious Battle.
So you used to put ships on each side of the game board, and you would just have to guess where the ships were.
Yeah.
okay.
Show you a picture.
And it actually has 100 spaces, which seems like this game would take forever. Sometimes it can, but most of the time it goes decently quick. Because the ships you're given take up a total of 17 spaces. Like you've got a battleship, which is 5 spaces long. And then you've got your, I don't know the real names. I only know battleship because it's the name of the game. Is there any other? Shoot, that's my next hour. There's one kid that knows all about ships. What are all the other ships called again? Destroyers?
I don't know.
Okay, destroyers sounds like a good name. Aircraft carrier. Isn't that a battleship? Oh, I know nothing about ships. I know how to go on a boat on the water, but I know nothing about like what they're called. Okay, but anyway, in the game you're given a bunch of different kind of ships because they're all different sizes. So you put them all over the game board, and they take up 17 spaces. What's the probability your first guess, that's what the play means, what's the probability your first guess is a miss? Which is actually most of the time. Like it's very rare that your first guess is a hit.
Will you subtract 117?
So we know that 17 of the spaces would be a hit. And so 17 of the 100 spaces would be the probability of a hit. And so we could take, oh, I have it's at the bottom, I'm sorry. We could take 1 or 100% if we did it as a percentage, minus the chances of you hitting a ship. So 17 out of 100 is hitting a ship, which means 83 out of 100 would be missing the ship. Now your probabilities change a lot once you get a hit, because then you can kind of strategically pick which direction you're going to guess next to that one. Because if you get a hit, then obviously the ship has to be somewhere near that spot you hit. This is sort of how that bad movie worked. They had to like fire rockets at a jumping alien, and they had they made the ocean into a grid, and so they were firing rockets at like B-12 or something, kind of like the game. There was about 5 minutes out of that 2 hours that was sort of like the game board. Very loose translation of the game. But that 5 minutes of that movie brought back good memories for me. It's fun. It's fun when you get to like destroy your siblings in a game. Does anybody need this up here yet? Questions on how it's set up? Okay? Now, I don't know if we're going to finish our notes today or not. I'm not like trying to fly through them because I don't want to just shove a lot of information down your brain. If we don't finish, no. I mean, I've got the homework set up for when we finish, so. And part of this is because these questions take a little while to write down, so that's why it goes slow. Oh, now this includes yesterday's. Probability with permutations and combinations. Oh my gosh. Now we're getting into hacking. Probability of trying to break a code. Now I'm going to guess that Manu is kind of weird like me. Where if I was given a code like 7654, I would think that was kind of strange. And I would want to sit there and figure out what's the possibility, how many other people would have gotten a code like that. That's the weird stuff I do. And I've never shied away from that. You got to be some level of weird to be a math teacher to begin with. It's just built into us. So we're trying to figure out what's the probability of getting a code of consecutive numbers. We'll take this a little bit at a time. Trying to tackle all the information at once will feel overwhelming, and you get anxious and give up. I know. You're not alone. There's quite a few people that do that. So that's why we're trying to learn how to take it a little bit at a time. These are the two things we're trying to figure out. Desired means what we're looking for, what we're trying to figure out.
This is a long problem.
Say it again?
It's a long problem. You have to write it down.
Oh, yeah. Yeah. I was going to say, there's not much to actually do. Okay, where some students have confusion is that they feel like you should have some sort of formula or some kind of math thing to figure every problem out, right? But sometimes you can just count them up. Like, you don't have to, like, why don't I just count up how many consecutive numbers there actually would be? 0, 1, 2, 3, that's a consecutive number. 1, 2, 3, 4 is a consecutive number. 2, 3, 4, 5. There's not going to be that many of them just because there's only so many digits. 3, 4, 5, 6. 4, 5, 6, 7. 5, 6, 7, 8. It's awesome that I can count. 6, 7, 8, 9.
Oh my god.
And then that would actually be the last one because 7, 8, 9, 0 wouldn't be considered consecutive. The ones I left off were what? Which ones did I write down? Numbers going upwards. So they're still consecutive if they go downwards. So I've got 1, 2, 3, 4, 5, 6, 7 that are ascending. You don't have to use the word, but ascending means going upwards. And then I would have 7 that were descending. So we have a total of 14 different library computer passwords that are consecutive numbers. And we didn't figure out reversed. It's hard to read, isn't it? Would it be easier if I just wrote them out? I can do that. 3, 2, 1, 0. 4, 3, 2, 1. 5, 4, 3, 2. 6, 5, 4, 3. 7, 6, 5, 4. There's 14 of them. How do we figure out how many possible codes there are? It's not 10,000, because I think somebody was probably going to say 10,000 pretty quickly, right? It's not 10,000 because this says you cannot have a number repeated. So every single number in your password has to be different. So it can't be repeated, which means it's not 10,000. Does anybody know where I got 10,000 from right away? Maybe I should have started with that. Well, 4 numbers would make up 9999. So that'd be 10,000. 0 to 9999 is 10,000. How do we figure out how many numbers there would be? This is using yesterday's information. So if you,
1,001.
what'd you say, 10,001?
1,000.
Oh, are you looking at the notes?
No.
Okay.
Oh, is that right?
Wouldn't it be
be NCR, so it would be like 9C4.
Very close and very good. It's going to be 10P4.
Oh.
So C4 would mean they're grouped together. Your password does matter what order the numbers are written, because like a password of 1, 2, 3 is different than 3, 1, 2. So combinations would be if the order of the numbers didn't matter.
I did combinations. I didn't
Ah.
see that.
Why did you put 10?
0 through 9.
Oh, the numbers.
There's 10 numbers.
And then a 4-digit code.
4 because we have a 4-digit code. And we want to know what's the chances of us picking 4 numbers. They have to be in an order, and they would automatically have to be different, so that's permutations. And I think it's a big number.
5,040.
That's it? So it's almost half of the numbers are cut out because there's repeated? Interesting. There's our probability. 14 over 5,040.
Yeah.
The permutations and combinations we learned yesterday actually get used quite a bit when you're trying to figure out total possibilities. Okay, I don't think we actually have that much left. Okay, can't see anything. That's awesome. What the heck is that? Oh, I wanted that button. Oh, I'm wrong. We got a lot left.
Oh.
Well, whether that's good or bad, I don't know. We're not going to finish today. But that means you get time for work tomorrow. It will be tiring today. Oh, never mind. We don't have a lot of. I forgot. I put these in the pages. Yeah, it just takes forever to write the problems down. That sucks. I know. I don't have any way around that. Geometric probability probably makes a lot of sense to you. Emma, you're on your phone. Now, this is definitely going to be considered theoretical probability unless you actually do an experiment and find out the chances. Now, that picture that's there is probably an extreme version. Can you guys put your phones away? Like, you make it sound like you have zero time for conversation outside of other stuff. Jake, you still got a bunch of stuff to make up.
Yeah, I know.
Today would have been a good day.
Okay.
So this picture that's up there is an extreme version because it's probably like the most complicated one you'd see. Most of the time they are much easier shapes. Like it's going to be a rectangle or something like that. And if you want to know the probability of it hitting the gray area or the white area or something like that, you're going to have to compare the sizes of the shapes. And that's all we're going to do for geometric. It's called geometric because you're comparing the sizes. I mean, theoretically, you can call it geometric because they're shapes, but whatever. Most people have an easier time thinking about this is if that shape is sitting on the ground and you drop a dart above it, you know, what's the probability that dart is going to land in the gray space? I guess we could think of it as darts. That's probably easy too, huh? If you think of a dartboard, you've got red and black pieces all over the place. You could figure out, I suppose it's 50-50 though, huh? No, darts, you don't go by red and black though. You just go by the numbers, don't you? I don't even do darts that much. You just go by the numbers. And I know the rings are doubles, triples. So yeah, the colors don't mean anything. I suppose they just do the colors to make it easier to see.
Do you want to do
Just do a rough picture, right? You don't have to. Okay. Yeah? I always record this hour.
Sometimes I forget that, so I just do it.
Mm.
Usually you said, oh, I'm sorry.
When it's like
Oh.
a white square with like a really gray around it, you know he's recording.
If
Or
it's
a
what?
rectangle.
What'd you say?
Because when you're recording, it like cuts off all the extra stuff.
Oh, I thought you were talking about the picture up there.
No.
Yeah, what you're saying is correct.
Yeah.
Yep. Yeah. The recorded area is the break. Did you find your phone? So yeah, if it's being recorded, it shows what's being recorded.
I see.
Okay, so let's figure out the probability that the point hits the shaded section. So what we want to do is we want to figure out how big is the shaded piece compared to the whole piece. Liam, we got to wake you up. You look tired. You've been playing with Play-Doh for like half the hour. I know. Okay? Can you help me with anything up there? That was fast. You just said no immediately. How come? You don't remember how to find a circle? Huh? You guys were in geometry last year.
I don't remember it.
I haven't been in geometry for like 30 years and I remember.
I didn't do good in geometry.
It doesn't matter.
Per usual, so.
You guys act like your teachers are smarter than you. They're not. You guys have to understand your teachers are just normal people.
Oh, you're
Yeah, but you do this for a living.
Yeah?
So you're really
So do you.
smart.
You're a student for a living.
But
But
you choose.
I don't get a choice.
Yeah,
you,
choice.
you get a choice.
You think I can't quit if I want to?
You could.
Right, so I have a choice.
But it's different.
It is.
Yeah.
You went to college to be a math teacher or something.
I didn't. I didn't
Or-
actually start as a math teacher.
Oh,
But you got your degree.
Mhm.
Yeah, yeah.
so you're smart.
teacher did you used to be?
No, I didn't go to school to be a teacher. I went to school to be a graphic designer and computer scientist. And then my work study job in college was in the tutor room. So I worked for the math department and I would tutor other people and then sub for the professors who were gone. I liked it.
Then you wanted to be a teacher.
Yep.
You changed.
I changed.
Most people do change.
I was part of the 75% of people that go to college and change their majors halfway through. Okay, Liam, I gave you a lot of time to find out and think and ask. You telling me in that whole time you never even thought to ask anybody around you?
I thought you were gonna answer those.
No.
Pi r.
I wrote it up there, pi r squared.
Isn't r the radius?
Yes.
And the radius is.
What?
Yeah.
Calculator? For what?
Pi 6.
Oh, I'm just going to leave pi in the answer.
This is for.
Yeah, okay. If you were going to do 3.14 for pi, then yeah, you definitely want a calculator. I'm just going to leave pi in the answer actually. So, okay. So how do I find the whole picture, the big circle? How do I find that size? That's easier of the two. How big is the big circle? Okay. Is that the radius, diameter? Diameter. Good, good, good. So the radius is
6.
3. 3.
Oh, yeah.
The diameter is all the way across the circle. Radius is half. My God, you guys did it. Ignore everything in geometry.
I'm sorry. I have short-term memory.
Okay, so radius is half of a circle.
Oh, yeah, that's right.
So the radius on the big picture is 3. So if I put 3 in place of the radius, then this would be 3 squared, which is 9. So it'd be 9 pi. But in fact, my answer is, why is my answer 4.5 pi?
It's only half a circle.
Half a circle. Good.
Oh.
It's really easy to forget that part.
What?
Pi r squared is for how big a whole circle is, but we've only got half a circle. It's really easy to skip that part.
But it's only half a circle, so you have to.
Okay.
divide it in half.
Oh, yeah, okay.
Instead of calling on somebody for the shaded part, does anybody think they know how to figure out the shaded part?
Nope.
Nope.
Not at all.
Jack?
Like, find what the, like, environment.
Perfect. So think of this as if we took a scissors and cut out that 4 and the 2.
I'm so
You would subtract them from it. I mean, that's the same as cutting them out. So I'm going to take the big circle, 4.5 pi, subtract this circle, which is a radius of
2.
2.
1.
So this is pi times 2 squared, so 4 pi. Cut it in half.
Minus 2.
Minus this little circle, which has a radius of 1.
1.
So that's pi times 1 squared, which is pi. And then take half of it.
What? Oh, because the radius is
1.
One, so
And then when you
half.
square it, it's still 1.
and
But
the
then
half.
half. Okay, so the shaded part is 4.5 pi, which is the big circle. And then you subtract off the 2 little white ones. And so we end up getting 4.5 minus 0.54 minus 2 pi, divided by 4.5 pi. The reason I left the pi on the thing is because I knew they would cancel.
Oh.
You could have done this as a decimal all along and it would have been just fine. I just didn't have a calculator, so I didn't. So 2 divided by 4.5 is 4/9. 4/9. And as a decimal, I think that's 45.45. No, what was it?
0.4.
0.454545.
No.
4.
Oh, 44.4. And yes, you're allowed to use your calculator on all this. I just don't have one next to me, so I'm trying to do it in my head. This one is probably going to feel like the most confusing to you because it's got the most things in it. Even though some of the other questions are arguably a lot harder, this is one that the most students have the most trouble with. Sadly, because I think you want to rebel and black out geometry. And so anything that deals with shapes is just kind of like met with resistance.
Okay, I have a question. So when she put it in the calculator, she put 2 over 4.5 and got 0.444. But why did you put?
decimal over?
You should see some.
Oh,
Times by 100.
if you want to write the answer as 0.444, you can.
It's still the same.
Yes,
Okay, perfect.
they're all the same answer.
Okay. I just.
So when you get to your homework and the tests, there's lots of ways you can write your answer and they'll be accepted.
Okay.
I'll stop there. So we'll clearly finish tomorrow.